Data Science and Artificial Intelligence, and what is this lecture about? And why is this lecture named like that, Data Science and Artificial Intelligence? So you could just name it like AI or Data Science or whatever fancy term. And in the following, I try to explain you a little bit why we named it like that, why we used this clunky name for this program. So yeah, another way is how to explain to your parents, friends, and friends what you are studying here at Saarland Informatics campus. And the naming has a lot to do with buzzwords. So buzzwords is something that is frequently used in the media, in the press, or even in movies. So one buzzword in Germany, of course, is Künstliche Intelligenz, AI, in German, KI, yeah, KI. And everyone is mentioning Künstliche Intelligenz, artificial intelligence these days, for whatever reason. Yeah? If you open up your refrigerator back home, a light is going to switch on. There's an AI switching on that light these days. Yeah? The same when you switch on any other light, when you do anything, everything is AI nowadays. No one talks about computer science anymore, and that's pretty weird. And when you are in meetings related to computer science, AI, or data science, or whatever, you frequently are in situations where there are misunderstandings. So there are people where one woman says data science, someone else says AI, someone else says big data, ML, data lake, and you don't really know what they're talking about. So there are many misunderstandings in the room. So that's one effect you can observe. Yeah? People use certain terms, but they don't really understand each other. And the second problem is that these days, it's a little bit like in medieval times. In medieval times, it still exists today, though. But there, you didn't have a real you didn't really have medical sciences. So there were people claiming, for instance, hey, this water will heal all of your diseases. Yeah, so. That's basically snake oil. That's the term for that in English. So we're selling stuff to people, and they were believing, oh yeah, that will help me. That water that was treated like whatever will heal me. Yeah? Those people were called quacks. Yeah? So they were pretending that they had experience in, say, medicine, and people would fall for that and buy it. And the same happens today with terms like data science, AI, you name it. Huh? So data science will cure all of your problems. Yeah? Whatever problem you have in your company, you only need some data science guy, and everything will be fine. And the same applies to AI, of course, or any other buzzword term you may use. And of course, you're all smart. You believe you won't fall for that. You won't fall for that trap. Well, let's make a small example to explain you that you already fell for that trap. Yeah? And I phrase it as imagine you're in a TV shop and you want to buy something. You want to buy a TV. And for the moment, there are two persons here. One's a TV expert that's trying to sell stuff, and then there's a woman that tries to buy stuff. Don't get me started on gender things. I will switch roles in a moment. Yeah? So for the moment, the guy is a TV expert, and the woman is trying to buy stuff. And how is the TV expert advertising these things? Well, he says things like, yeah, this model even has hyper-ray ++ rendering. Yeah, that sounds really cool. I mean, wow, maybe I have to buy that. It has a 500 hertz rather than 250 hertz. No human being can see the difference between 500 hertz and 250 hertz, but it sounds so much better. Yeah? So maybe you want to buy it. This has ultra HDMI. Yeah? So he uses many terms. Some of them have a meaning, others don't, in the hope to trick the woman into buying the more expensive stuff, let's say. Yeah? And how would that look like in a big data shop? Now here again, a similar situation, but the shop is not about selling monitors or TV screens. It's about selling big data solutions. And they're symbolized here with a big cylinder for the moment. Yeah? So there's someone trying to buy some big data solution. And as I said before, I will switch roles. Yeah? I have to adjust the terms here, of course, a little bit. So there's a layman and there's a big data expert. Now the woman is the expert trying to trick the guy into buying some stuff. And she will use terms like, oh, that's a leading NoSQL data lake solution in the cloud. Yeah? There are three terms in this single sentence that are undefined: NoSQL, data lake, and cloud. They're all super fuzzy and very difficult to understand. This is a quote I stole somewhere from a web page, from a real vendor. Yeah? So we'll see these things. Or you say blockchain enabled. Yeah? Oh, blockchain, yeah? Well, whatever that is. Yeah? Sounds cool. I have to have that. My fellow manager has it as well, so I have to have it as well, right? AI ready. Yeah. Oh, that's cool. Oh, it has some AI, whatever that means. Yeah, cool. Built on the Lambda architecture. Again, stolen from a web page. Or IoT, yeah? Or IIoT, yeah? Or IDIoT. Yeah? That's only something what she thinks. Yeah? And so what is the problem here? The problem is ambiguous communication, because what happens here in these kind of communications is, so one is saying big data, and so big data is actually just a symbol. Yeah? There's a meaning attached to that. So how we use words, so if you ever had a linguistics class, yeah, if I write big data here on the blackboard, yeah, that's a symbol for something. Yeah? I use characters and bad handwriting, but in the end you will be able to decipher, oh, that's big data, and there's a meaning in your head associated to that. Yeah? The same holds for any kind of symbol. So if I speak it, yeah, the sound of my voice, that's a symbol. The stuff that's written on the slide is a symbol. So that's just half of the story. The other half is, okay, what is the meaning attached to that? What does big data actually mean? Does it mean large? Big means large data. What is large? Large in comparison to what? Is a terabyte large, a gigabyte, a petabyte, a megabyte? I don't know. It's very fuzzy. Yeah? There are various definitions. So for some people, big data means, oh yeah, that's mass surveillance, NSA stuff, so forth. Yeah, that's big data, sure. Yeah? Or it's some specific software component like Spark, MapReduce, and NoSQL, you name it. Yeah? The problem is, it's unclear at the moment which arrow, do you see the arrow here on? Of course not, yeah. Which arrow is meant by that specific person. So what happens in the communication is, now the second person hears, oh, he said big data, but may have a different meaning associated to that. Yeah? So let's assume that the blue person here, big data means MapReduce, but for the first it means large data. You have a translation error. Yeah? Actually, large data got translated to MapReduce. Yeah, you see the problem? Because the term is ambiguous, if you go back, the term is ambiguous, it's not clearly defined, the meaning is not the same for those two persons, you get a translation error. And with that, all kinds of problems may happen, actually. Yeah? And clear communication, in contrast, is something like that. And that happens at university, and it's very important. So in each and every discussion in my group with students and whatever, we make sure that we communicate like that. So if you use any symbol, and this is a symbol you don't know yet, you learn about that in the fourth semester already, so don't worry, just for you to make the point. I say relational algebra, and there's a PhD student in the room who hears that I'm saying that, and it's crystal clear what we're talking about. There's no ambiguity whatsoever. So I mean something, has to do with Greek letters and whatever, has some concept from my research area, and if someone else, where someone else means a PhD student or someone who attended my lecture in the fourth semester, hears that, it's crystal clear, he meant this stuff. So there's no translation error. Yeah? And that's a problem here. So here, relational algebra in my brain got translated to relational algebra in the PhD student's brain. Yeah? And that is a difference. With buzzwords, it's something like that. You have something like AI, and it may mean so many different things, which increases the number of misunderstandings that become possible due to that. Maybe deep learning is meant, or knowledge representation, so machine learning, NLP, robots, logics, whatever. So many possibilities, and that makes it very difficult to use these terms in a real technical discussion. Yeah? And you see it in phrases like that. Company X wants to solve problem Z using an AI. Why an AI? Wouldn't some computer science thing be enough? Why does it have to be an AI? I don't understand that. And so here it's the same confusion. So what you see these days is that AI gets translated to computer science very often. And what you can do, once you understood that, you can actually create a buzzword bullshit landscape, as I call it. So basically on the x-axis, I depict the number of meanings associated with a term. Y-axis doesn't have a meaning, it's just for visualization. So on the left, I put some terms, again, from my area. You don't have to understand it, don't worry. Yeah? That is stuff that is clearly defined. If I use any of those terms in a discussion with PhDs, no ambiguity. Yeah? Now, further you go to the right, the more ambiguity may happen. Yeah? That holds for things like large data. What is large data? Data science, deep learning, MapReduce, Hadoop, and so forth. Further you go to the right, cloud is a good example. Yeah? When cloud computing was invented like 20 years ago, it had specific technical ideas behind it. Nowadays, the cloud is used as a synonym for the internet. I uploaded it into the cloud. Means I uploaded it into the internet. Sometimes it means that. Yeah? So it's very, very difficult. Yeah? And AI, big data, NoSQL is even more problematic. So my advice, and that's something that's part of the learning experience in a study program like that, is whenever you are in a technical discussion, try to use terminology here on that axis that is clearly defined. If in doubt, ask back. Yeah, so if I'm in a room with a PhD student and there's a term where I feel like, oh, that's not, maybe we have a different understanding of the term, we say, stop, okay, let's talk about the term. What do you understand by that term? Yeah? Then we define it clearly and then we use it like that. Yeah? Also happens when we use terms that may mean different things and we say, okay, now we say term, so term may mean this and term may mean that. Okay, we have to use a different variable name for that and say term 1 is now this and term 2 is now that. Let's continue discussing. Yeah? So it's very important to get these things right. So technical discussions is here. If you want to have venture capital, you always use stuff here. Yeah, it's very important. If you want to become a manager, yeah, footnotes, stereotypes about business administration, you want to talk here, okay? Yeah, but if you want to get anything done on the technical level, you're in this space. Yeah? Once you're in industry, you will be forced to do these things because it's so much cooler. You want to impress your boss, yeah? Then say something, oh, I developed a query optimizer in a database that uses cost-based optimization. Okay, yeah, You go to your boss and say, oh, I developed a NoSQL big data solution that's AI ready and uses blockchain. You get a raise, you get promoted, okay? That's how the world works. Yeah? Okay, but here we are not in the industry landscape, we are in a university world, and here we have to use non-ambiguous terms in communication, at least try to use them. It won't always succeed, but it helps a lot if you're clear with your language. Yeah, what I do typically is, I'm not sure whether you know these Rorschach tests. It's something that was developed in psychology decades ago. And the idea is psychologists show such a picture to a patient, and the patient has to say what he or she sees. Yeah? You just see the picture, and then the patient says, oh, I see a car, or I see a bicycle, or I see my ex-wife, or something like that. Yeah? And based on that, the psychology can I always see ex-wives or always see bicycles. Maybe that's the problem. Yeah? And you can do the same with these buzzwords. You just say AI. That's a Rorschach test to someone, and then see what the other person interprets into the term. And that's sometimes very interesting. Yeah? I play that game very often. It's a bit, okay, it's fun. Yeah? I invite you to do that. Okay, so much about buzzwords. Another effect when talking about AI and ML, there's a lot of press about that, is that in reality, when you want to build a real system, you will quickly feel, yeah, there is some AI, there's some ML, but there's so much other stuff that's also super important. Yeah? And there's a picture from a paper I like to show in that regard. Yeah? So when you build something bigger, typically you end up having to do many, many different things. Yeah? Each box is some huge amount of work you have to do there, and can you spot the little ML part here? Yeah, that's often what a real project is about. So doing machine learning, data science, AI sounds like, hey, we train deep learning models to do X, Y, Z. Yeah, but that's this part of the picture often. There's so much stuff you have to do before being able to train a model. And we will also look at that a little bit in this lecture. So, okay, so if buzzwords do not help, what is DSAI about? So how is there a way to define what DSAI is about? Actually, the answer is no. The only thing I can do here is to give you some idea about the applications you will work with or are interesting in the context of this study program. Not so much what it is. In the mathematical sense, DSAI equals like in math. No, that doesn't work. But I can give you some intuition, some sketch on what this entire field is about. And to do that, I will show you some applications that you will see frequently. So who heard about Go? Yeah. So Go is a game from China, Asia, some played there. And for many, many years, computer scientists believe it's too difficult to ever be solved by a machine. In contrast to chess. Chess was solved like in the 90s, and from then on, the best human players couldn't compete anymore with the machines in the 90s. But Go is way more complex. It has a larger state space, as it's called, means too many possibilities. You can't explore them with a computer meaningfully. That was changed, I think, now almost 6-7 years ago. And from then on, computers were better. So there was an AI solution. It was a combination of different techniques. Jörg Hoffmann will explain that in more detail. But it was a major leap. And it was very, very, very surprising that a machine could play better than a human player. And it had ramifications in the sense that the way how the machine played taught real players a few tricks. For instance, in Go, there were certain rules. You shouldn't do this, you shouldn't do that. Early on, you shouldn't do this move. That was called a forbidden move. Well, what did the computer do? It did exactly that move, because 18 moves later on, that would make the difference to winning or losing. Yeah? Now, how the computer played changed how human players played afterwards, and they had to revise their rule sets on how to play Go, actually. Yeah? So there was a teaching backlink. Yeah? So that was a major revolution in the field. Then production planning, how to organize your company, yeah? How to plan in a company, which machine does what at what point in time, that has been revolutionized in the past 10 years. Style transfer, who has seen that? No style transfer? Okay. So the idea is as follows. You take a picture, a photograph on the upper left. You take a painting on the lower left. And then the computer asks the computer, okay, change the picture to look like as if it were painted in the same style of that painter. That's called style transfer. So the style used in that painting should be imposed on the picture. That's called style transfer. Yeah? And here's another example. So upper left is a picture, and now you can see that picture in the style of different artists. Here's a Van Gogh version. This is Munch, and this is, I don't know, I'm not an art expert. Yeah? That's what you can do with that. And that goes that far that there was one paper that did that in 3D. Yeah? So they didn't only analyze the 2D image, but analyzed the paintbrush strokes of a painting and then used a 3D printer to create an image that looked like, I think it was Rembrandt or something at the time. And then they gave it to an art expert. And the art expert said, yeah, that's Rembrandt. I didn't know that one. Where did you find it? Yeah, that is the level of what these techniques can do. Yeah, there are also scary versions. One is Deep Dream by Google. The idea here is that you, how is it explained? That you use a specific AI, I think this one was trained on eyes or fish or something like that, and then you can ask it to amplify what it sees. So this AI will try to see eyes or fish or whatever and whatever it sees and amplifies it. Yeah? So you get really nightmarish images like that. Yeah, and the cool thing, and that is really the big revolution, that one of the big revolutions, there are many revolutions here. So this is a very early work that was done. And here the task was, okay, given a picture, tell me what this traffic sign is about. Yeah, many humans have problems with that. You see that when you move through Saarbrücken every day. Yeah, but here the difficult thing is teaching machines to understand an image. Teaching a machine to understand video or sound is super hard. Yeah, I thought that until 6 or 7 years ago, because there's an entire sub-area in computer science called computer vision that's exactly doing that. So you have a picture, you give it to the machine and ask the machine to label it, to say, okay, that is give way, Vorfahrt gewähren, Vorfahrt achten, dead end street, all of these signs. Yeah? That's a relatively difficult task for a machine, but there are now techniques that can do that better, and some can do that very well, and sometimes those techniques are better than humans already. They have superhuman performance. You have to give them a set of pictures, ask the machine, label those pictures, tell me what you see. You do the same thing and give it to humans, and the machine is better. Yeah, that's where we are in that area. Yeah, and this is this slide is, I think, 4 or 5 years old. I don't really remember. The paper is. Let's check the paper. No, the link doesn't work here. So, but basically, what you see here is that's called text to image. So you tell the computer the text on top. Yeah. So the top left, you say the bird is red and brown in color with a stubby beak, and then the computer has to generate an image that matches that sentence. So you describe the image you want to have, and the computer will synthesize, will create an image for you. So this is not an image that comes from a database. It was a photo that was taken by someone before. This image didn't exist before. This image was created by the machine. Think about that. Yeah? A machine creating an image such that the image looks as natural as possible and matches a description given by some text. There are more examples here, like the fourth here, in the middle, this small black bird has a short, slightly curved bill and long legs. That was 4 or 5 years ago, and then things exploded. They exploded in tools like DALL-E 2. Who has heard about DALL-E 2? Yeah, more people have heard. It's the same thing, just incredibly, insanely awesome. Yeah, let's look at that a little bit. It's the same. So this is the web page is here. You can go there. Now it's open for everyone. You can register and try it out yourself. It was closed until months back or something, but now it's open for everyone. You can go there, enter a text, and the machine will try to create an image that matches your textual description. You just think about what that implies, yeah? In particular for photographers, yeah? Stock photography, people producing pictures that are used in books and newspapers to illustrate things. Those fields will be gone very quickly. Yeah? So that's basically now available for, there's not only DALL-E 2, there's other, there are other tools that do the same thing. One is Stable Diffusion, you might have heard of that. There's DALL-E Mini. They all have various kinds of quality and properties. Yeah? So you can try out any of those tools. This is the tool by OpenAI. So any suggestion, what should I type? Yeah? A Jedi fighting an AI. Okay, Jedi fighting an AI. We can be more detailed if you want. Maybe better. Maybe I have to write capital. And Jedi also. Huh? Underwater. Okay. Sure whether they have pictures of Saarbrücken. I'm not sure. No, maybe I don't know, you can never give them. I don't know anything. Details seem to help. Yeah.
Inducing animation style.
Ah, yeah, cool. In Disney animation style. That should be enough for the moment, okay? Generate. Then you wait a little bit, hope for that the internet doesn't break. And then you get 4 proposals, yeah? Let's see, sometimes it works well, sometimes not. And what is the AI? Maybe we can have more detail on the AI part, okay? Any idea? Maybe didn't understand it. Artificial intelligence, artificial intelligence. How many? Intelligence. Is that correct? Oh yeah. Let's give it a try whether it makes a No, not much, right? The JDI, that's not bad. But the AI part, it didn't get right. Yeah? Anyway, you see where that leads to. Yeah? You have to play a little bit. Actually, there are separate AIs now being trained to help you phrase the text correctly. Yeah, this text is called the prompt. Yeah? Now, whatever you have in mind, you can give it to that AI. It will generate a better text prompt that creates a better image. Yeah? And though these tools are now available, they even, so here with Study, you can integrate it into your Python framework. You have to pay for that eventually, so you get a certain number of credits for free, but if I exhaust them, I have to pay more. But basically, you can build it into your application and just call a little Python API. Completely insane, completely insane. Okay, where was I? Here's my mouse. Yeah. Yeah, and of course, I mean, and then I think DALL-E, a couple of months back, there were a lot of discussions in the media, and then 3 or 4 months ago, there was still the problem to get access to it. Then a different version appeared that was called Stable Diffusion. Stable Diffusion has the advantage you can download it. This is a web page. I don't have access to the model that's behind that, to the software. I just have the prompt, like in a search engine, and then the software on the web somehow produces the image. Then there was Stable Diffusion. Stable Diffusion you can download, you can tweak with the model, you can do really, really fancy things, movies and stuff. And then I was saying, okay, it will be a couple of, in a couple of years, people will be able to do that in 3D. Couple of years was wrong. Yeah. So this is now the 3D version. It just appeared. You make a prompt, and a 3D character appears. That's a model that you can download and use directly in your 3D software, like in a computer game, for instance. Yeah? You want to have a character, typically you have to ask a super expensive graphics designer, hey, please create a character. Here you just say, oh, it should look like that, yeah? And then you can download the stuff and use it directly. Speechless, yeah? And you see where that leads to. Eventually you can create your own movie. Yeah? You give it a book and you ask the AI, hey, no one ever did a movie on that. Could you do a movie for that book just for me in my preferred style as an action movie with Bruce Willis as the main character and those other characters, and don't make it too scary, okay? I don't like these scary movies, and don't make it too dark. Yeah? Maybe maybe it could have some musical elements, that would be cool, and a comic here and there integrated if you want. Boom. Yeah, maybe 5, 6 years down the road, then we will see that. So it's absolutely crazy times in AI. If you want to catch up on those new developments in AI, I do that on a YouTube channel that's called 10-Minute Papers. That's really cool. Does anyone of you knows? Do you know 10-Minute Papers? Some, yeah. It's really cool. Look it up on YouTube. There's a guy, a researcher from computer vision, presenting the latest research in computer vision. and he gives updates on these things. That was also given by that guy. That's how I detected it. So, as I'm not in computer vision, I'm a database guy. Yeah, then all these interpreters translating text. Yeah, so you see a booth like that on a big conference. If there are people from different nations and there are people translating, those times will soon be over. Yeah, there are now AI models that can do that. And again, what happened here is those models become more and more available. Again, OpenAI has a model that's called GP3. And it's really crazy what it can do. It can translate all kinds of text. It can, I can give it computer code and it writes an explanation. That's called documentation. Yeah? You will learn in this program that when you write code, you should write some documentation explaining in a natural language what the code is about. Or you give it to GPT-3, it does the same thing. Yeah? So you never have to write any documentation anymore. Oh, that's so cool, right? No one wants to write documentation. Do translations, do text summarizations. You give it a long text that's complex, it will summarize it in a simpler English version that is easier to understand. Yeah? And as I said before, the quality of that is outrageous sometimes. Yeah. Yeah, the other big thing happening, that's self-driving cars, of course. People have researched that for decades now, and they're already driving around in San Francisco and Germany now. Germany has started recently with that. That will appear. And there are many, many research challenges attached to that. In this course, we will look at that as well. Professor Van Schiele will give you some material on that because it has so many challenges. The most important, of course, being making it safe. Yeah? You want to build a car that doesn't hurt anyone, which turns out is a very high goal. Maybe you want to have a car that hurts less than a human driver. Yeah? If you look at the accident statistics, how dangerous human drivers are on the streets. Yeah? Actually, where you want to be is you want to have a car that's better than that. It doesn't have to be perfect, but at least better than that. Would make a huge difference, given the millions of people dying every year. I think it's around 1 million people per year worldwide dying in car accidents. Truck drivers, the same thing happening. Fully automated trucks are on the horizon. Same for any kind of car, of course. Cab drivers. Yeah, so cars can be driven automatically. Package deliveries, yeah, of course, that's the last few hundred meters. How do you get the package from the car to the house, yeah, to the post box? But that can be done by smaller robots. Yeah, that was, I attended a talk a couple of years back. There was a head of AI of Tesla giving a talk at the time, and he wouldn't call the car anymore. He would call them robots. Yeah, they're robots which look like cars accidentally, yeah, but it's a robot actually. And he also explained interesting things on how these cars at all times collect data. They video record their environment classified using AI and machine learning tools. I'm not sure for data protection rules in Europe. I'm not so sure about that, yeah, but that's what he told us. So basically, these cars try to understand their environment, try to also compute. Okay, they try to. So the machine has to understand. Okay, do I understand what's in front of me, or is it that I don't understand what's in front of me? Yeah, yeah. Because there may be a situation the AI can't handle, and then it has to give back control to the human driver. Yeah, this is something the AI has to understand. It was a very interesting talk at that time. Yeah, the other thing that happens is in software. So traditionally, software is being written or was written by developers, computer scientists, programmers, you name it, different levels of abilities. And how you imagine a program is basically it's this big blue box, and all of the blue stuff was written by a human. This is changing these days. Again, we understand that some of the parts can be replaced and can be automatically generated by an AI, by a machine learning model, or ML for short. Yeah? So larger and larger parts can be replaced by machine learning. There are many interesting things happening in that space. Actually, my group's also working a bit in that area. Scientific data, yeah, there's this super collider at CERN, how to analyze that data. AI can be used for that. Astronomy, scientific data is super interesting. AI or machine learning or whatever you name it methods help you to classify images. Yeah? For instance, detecting exoplanets, planets on different solar systems. Yeah? That was another explosion happening through ML, computer vision methods. Yeah? Now they have these astronomers have these large catalogs of stars and planets, and with the help of DSAI methods, they could detect many more exoplanets. Yeah, then building systems that are distributed. For instance, just your bank account. How do you create a system like that that actually works, that's available at all times, that detects fraud at all times? Yeah? That detects that your credit card was stolen and someone is trying to deduct money using it in a different country, all of these things. How do you make a system robust like that? Shopping systems, yeah, I don't want to, big shopping platforms, how do you make them such that they work on a worldwide scale? Huh? That they scale for a different planet or a different galaxy, yeah, if you want. The same with search engines, yeah? How to scale a search engine across an entire planet. Or content delivery. Content delivery is a hidden system many web pages use to make sure that when you want to watch videos, say on Netflix or YouTube, that the video appears instantly, and that there's no delay. There's a whole network of machines that make sure that these things happen, and that has a lot to do with big data, actually. Yeah? So there's a big tsunami, a big wave that's running over traditional computer science. But there are also, as alluded to already with the astronomy part, there are other sciences that are affected by those methods in DSAI. And one is radiology. Yeah, so that is a profession I can highly recommend to follow because there are already benchmarks clearly indicating that machines can be much better than human radiologists. You can do, again, you do the A/B testing. You give a group of radiologists and an AI. Yeah, it gives the same set of pictures to the radiologists and the AI. Guess who wins? Yeah, not in all cases, but in many. And a few years from now, yeah, then there will be the question, okay, so what is a human doing there? Writing the bills? Sorry. Of course, then there are always discussions like, hey, yeah, the AI will be an assistant to the human. We are not going to replace the humans, yeah? Sure. That's always to make it easier for the humans. It's the same argument always. Yeah? So if humans are afraid that they may lose their job, the argument will always be, no, it's just helping you to be more efficient. Yeah, but okay, that may be true for a couple of years, but eventually jobs will get lost because the AI will be better. And there are a couple of studies were done in that space that already showed the potential of that. Yeah, then that also holds for other fields in medicine, like dermatologists, cardiology, this heart recording, this, in German it's EKG, electrocardiogram, can be classified better by machines. Pathologists, laboratory parameters. Surgeons is a bit more difficult because you need a robot and need to steer it directly. That's a bit longer down the road. A couple of studies there, just highlighted here, some news articles about that. Same with physics. What we did was lightning prediction in one paper, played a little bit with the data, so we tried to predict when will lightning strike, or with which probability will lightning strike. We could show that actually with machine learning you can do something there. Seismology, what's going on here? So many people opening the door. A seismologist is the idea that you want to predict an earthquake before it happens. So we played with that data a couple of years. It's a very difficult problem. Others continued, and now you can at least predict an earthquake in a lab. You can simulate the earthquake simulators that use large stone plates that are moved against each other, and in these lab environments you can predict earthquakes. But of course, a few years from now, let's see what happens. And then there's a dark side, of course, in AI. One is automatic warfare. You see it now in conflicts like in the Ukraine war, drone swarms being sent, and of course they use a lot of AI. No, we're still in the lecture. How difficult is it to keep this door? Ja, bleiben Sie mal draußen. Stellen Sie mir vor die Tür, gucken Sie, dass keiner reinkommt. Ja, Türsteher, kriegen Sie ein Brötchen. Mann, ey. Sorry. Yeah, and then, of course, things like social scoring. Yeah, so mass surveillance, the social scoring in China is basically every citizen has a score attached to his profile, his or her profile. If you cross a street, even though the traffic lights were red, yeah, your score goes down. If you say anything against the leader of China, your score goes down. Yeah, if your score is low enough, you won't be able to book a flight ticket anymore. Certain jobs become impossible. Yeah? So you give school grades to people based on automatic decisions, based on computer vision, based on surveillance. And that's, of course, a very bad development. Yeah? And we saw it here in Europe. With
I don't want to live in a world where
hear that?
Everything that I say, everything I do, everyone I talk to, every expression of creativity or love or friendship is recorded. And that's not something I'm willing to support. It's not something I'm willing to build, and it's not something I'm willing to live under. So I think anyone who opposes that sort of world has an obligation to act in the way they can.
Yeah, that's Edward Snowden, of course. I think it was 2013 when he revealed the documents he took from NSA. So he had, I think, administrator level access at NSA. It was a big scandal. And that's a problem. Yeah? So global mass surveillance violating our fundamental rights, violating the Grundrechte in German or the constitution in other countries. There's an excellent book written by the German author Andreas Eschbach called NSA. I treat that book in my lecture in the fourth semester, Big Data Engineering. We spent a week with that book because it has so much to do with databases. Basically, in that book, he shows the problems you have already without video, without sound recordings, just collecting metadata. Metadata is who did the phone call with who at which point in time, who bought which item when, who spent that money with who at which point in time. That's metadata, tiny little data snippets that if you combine them, give you a lot of information. So that's the dark side, and we will handle that then in my lecture. But if you can read German, you're invited to read the book. It's really awesome. Yeah, and the other discussion is artificial general intelligence. So the possibility that AIs become so powerful that they outperform humans in general tasks. So the AIs I showed you here, computer vision or generating images from text, are specialized, super highly specialized. They can do this single thing, but not more. Yeah? What happens if eventually general intelligence appears, an AI that can do all kinds of things and is better than humans? Yeah? So it could be that also this the level of intelligence could skyrocket like crazy because the AI could develop methods of its own to get even smarter. Yeah, everything is possible, and the possibility is there. And the interesting thing, if you ask people, experts, whoever you want to ask about what they believe may happen, you get the entire spectrum from here's one example from Elon Musk. Mark my words, AI is far more dangerous than nukes. Yeah, because if an AI, of course, eventually says, no, why would I need humans? For what exactly? Yeah, you see what may happen. Yeah? And that is not a wild science fiction fantasy. That's a real danger. And scientists are discussing that. Versus, calm down, no risk here. That is what Jörg Hoffmann will say next week in his introductory lecture. So I preempted a little bit. Yeah? So Jörg is a little bit on the other side. Hi, Jörg. Right, yeah. And so it's very interesting. And they have been surveyed, they did surveys in the AI research community, and the AI research community is really divided. Yeah? And people saying, no, come on, everything is fine, you're exaggerating, you saw too many science fiction movies. and others saying, no, that's a risk, we should be more careful, as we are currently. If you are interested in that, read this book. That's really cool. Life 3.0. That was really fascinating because I wasn't aware of that divide. I always believed Jörg, and now I don't do that anymore. And actually, back in 2018, so Jörg and me, we sit on the same aisle, and we had our Christmas dinner. We were discussing the topic, and I said, oh, it's going to happen. It'll take 10 years at most. Jörg said, no, it's not going to happen. And then we made a bet. And now I have it in my calendar. I just showed you that in November 27th, 28, we will go back to that bet, whether there's an artificial general intelligence. Let's see. I'm just telling you that because if Jörg tells you that next week, no, it's no danger, you are prepared, okay? Yeah, so it's not, so this wave is not running only over traditional computer science, but over all of the sciences. So basically what we can observe are technology waves, depicted like that. On the x-axis you see time, so the different years, and you had different technology waves, like the personal computer in the 80s changed many things. Before it was mainframes, big computers, no one could afford them and buy them except big companies, insurances and stuff like that. Then computers could be bought by private persons all of a sudden. The internet, of course, was a big revolution, a big tsunami changing everything. But if you now zoom out a little bit, you see there are other waves. For instance, back in the days, there was electricity. Yeah, that was a big game changer, and you could switch on a light, and there was light in your room. You didn't have to fiddle around with matches and candles and stuff. Yeah, things got easier. You got electric power, electric motors and stuff. Then there were cars, of course, changed a lot. Then there was radio, radio transmission, but also as a medium. You could send sound to many people, be it whatever, the news message, be it music. Yeah. Then there was nuclear fission, changed a lot in how to get energy, but also in terms of warfare, of course. And there's one other wave we are seeing, and that's this one. Yeah, that's what you're studying. You are sitting on that wave, trying to ride the wave. Good luck. I hope you can surf well. Yeah, but I think it's the most interesting wave, definitely, because so many things are happening there. Yeah, okay, that is what I wanted to say about the introduction. Now let's switch to briefly for your program. In case you still have the questions, I wanted to show that. That's basically an example program of what you will attend. Some of it is in German still. Yeah, so we are here, Einführung, Data Science, Artificial Intelligence. You should attend Mathematik für Informatiker, Programmieren 1 and Ringvorlesung. That's your first semester. And the more you advance, the more you can choose. Yeah, that's the idea. Yeah. So Vertiefung means advanced lecture or core lecture. This orange means you have to do that. There's no way around. Red as well. That's math stuff you have to do. There's no way around. That's basically an example of how your studies could be organized in DSAI Bachelor, but you can also change. The other question that frequently comes up is this Anwendungsfach, application area in your Bachelor program. We have a couple of them. If you want to attend lectures in an application area, you have to register first for that Anwendungsfach. With Frau Summ in the Prüfungssekretariat. However, there's a rule. The rule is you only register if you actually attend a lecture in the same semester. Yeah? So you do not register now. So what you please don't do it. Please, what you should not do is you register now, and 2 years from now you actually attend lectures in that area. That's not good because there are limits on the application area. So each application area said, okay, we take like 5 students per year, we take 10 and so forth. Yeah? So there are limits, the number of seats that are allowed. And if you block a seat without attending a lecture, it would be unfair to your fellow colleagues. Yeah? So please only register if you're actually planning to attend a lecture in that area. If you see students who are registered but don't attend a lecture for 2 semesters, I will personally remove them. And I take the freedom to say you will not be allowed to take that Anwendungsfach anymore, okay? We didn't have problems so far with that. Yeah? I'm just saying you now with a kind of little harsh words, don't do it, don't try, please. Yeah? It's okay, you say, oh yeah, I would like to do it, and then a week later you fall in love, the love of your life, and you don't have time anymore to attend the Anwendungsfach lecture. That's fine. Yeah? Don't forget to write an email to us saying, I deregister, I have better things to do now. That's okay. Yeah? And then you can register again next semester or whenever you split up with your new love. That's okay. Yeah, so my message is, earliest is in spring 23, but you can also do it later. Eventually you have to decide. Okay, that's it from my side. I wish you good luck with your studies. See you.